So I'm going to be going over the chapter 2 review. For the first question, I want to solve the equation. In order to do this, I want to look for the lowest common multiple of my denominator. So I'm looking for the smallest number that x, 3, and 6 all multiply into. This is going to be 6x. So then what I'm going to do is I'm going to multiply each of my fractions by 6x. So when I multiply my first fraction by 6x, the x's cancel out, so I have 6 times 1. The second fraction, when I multiply, 6 divided by 3 turns into 2, and then I still have that x. And then for my last one, the 6's cancel out, so I have 5x. So then this is just a normal linear equation, so I want to go ahead and solve it. I'm going to start off by subtracting 2x on both sides. I get 6 equals 3x. I divide both sides by 3, and I end up with x equals 2. And then I just need to double check and make sure if I plug 2 back into my denominator, it would not give me a 0. So it wouldn't because it's just an x. So my answer here is just 2. On number 2, it wants me to write the quotient in standard form. So to do this, I need to multiply by my complex conjugate of my denominator, which is just changing the sign in the middle. So it's going to be 3 plus 3i over 3 plus 3i that I'm multiplying by. So then I want to distribute on my numerator. I have 4 times 3, which is 12. 4 times 3i, which is 12i. 2i times 3, which is 6i. And 2i times 3i, which is 6i squared. On my denominator, I'm going to have 3 times 3, which is 9. 3 times 3i, which is 9i. Negative 3i times 3, which is negative 9i. And then negative 3i times positive 3i is negative 9i squared. Where is my whiteout? So negative 9i squared. Then I want to simplify. So on the numerator, I'm going to have 12 plus 18i plus 6 times negative 1, because remember, I squared turns into negative 1. And then on the denominator, I'm going to have 9 minus 9 times negative 1, because my i's cancel out. Then I want to simplify some more. We're going to have 12 plus 18i minus 6 over 9 plus 9. I will give you more room on the test. So then I want to simplify more. I'm going to have 6 plus 18i on the numerator divided by 18. All three of these numbers are divisible by 6, so I want to divide all three of these numbers by 6. So that'll give me 6 divided by 6 is 1. 18 divided by 6 is 3. Oops, and I still have that I. And then 18 divided by 6 is 3. So this is my final answer. Okay, number 3 wants me to simplify the expression. Because I have a minus sign in the middle, I want to distribute that to all the terms that come after. So then I am going to have negative 4, negative 5i. Then I just want to combine like terms. 3 minus 4 is going to be negative 1. Negative 6i minus 5i is negative 11i. So this is my final answer. Remember, you always write the real number first and then the imaginary number. Number 4, I am multiplying. I can tell because there's no symbol in between the two sets of parentheses. So 5 times 3 is 15. 5 times negative 2i is negative 10i. 4i times 3, 4i times 3 is 12i. 4i times negative 2i is negative 8i squared. So then I want to go ahead and combine my middle terms. I'm going to have 15 plus 2i, and then minus 8 times negative 1, because I squared turns into negative 1. So I have 15 plus 2i plus 8. 15 plus 8 is 23 plus 2i. Number 5 wants me to solve the quadratic equation by factoring. The first thing I want to do whenever I have an a value that's not 1 is I want to check to see if I can divide it out from all of my terms. And this one I actually can. All 3 of those numbers are divisible by 3. And then I, of course, want to remember to divide the 0 by 3. So this just gives me x squared plus 6x plus 9 equals 0. Then I want to look for what multiplies to 9 and adds to 6. This is 3 and 3. So then I write my factors like that. Then using my zero product property, I'm going to take each of my factors and set equal to 0. Because they're the same, I'm only going to take one. So I have x plus 3 equals 0. Then I want to subtract 3 on both sides. I get x equals negative 3. If I had an a value that I couldn't divide out like that, then I would go ahead and use either the box method or the AC method that we've learned before. Okay. Number 6 wants me to solve the quadratic equation by using square roots. So what I want to do is I want to isolate my squared term on one side and everything else on the other. So I'm going to start off by adding 4 to both sides. I have x plus 3 squared on the left and then 4 on the right. Then I want to go ahead and take the square root of both sides. So on the left side, this cancels out my exponent. I'm just going to have x plus 3. On the right side, whenever I draw the square root symbol, I get a plus and minus. And then I have the square root of 4 is 2. Then I want to go ahead and subtract 3 on both sides. I get x equals negative 3 plus or minus 2. Because these are both whole real numbers, I can actually split this up and solve into 2 equations. I'm going to have x equals negative 3 plus 2. And then I'm going to have x equals negative 3 minus 2. So on the first one, negative 3 plus 2 is negative 1. The second one, negative 3 minus 2 is negative 5. Okay. Number 7 wants me to solve the quadratic equation by completing the square. So to complete the square, I need all of my variables on one side and all of my numbers on the other. So I'm going to start off by subtracting 6x on both sides. This gives me 55 equals x squared minus 6x. Then I want to make sure my a term is 1, which it is here. So then I want to find half of my b value. So 1/2 of negative 6 is negative 3. I am going to add negative 3 squared to both sides, and then I'm also going to switch the sides my variables are on. So negative 3 squared is 9. So on my left side, I want to factor. I'm looking for what multiplies to 9 and adds to negative 6. This will always be the 1/2 b value I got earlier, so that's going to be the negative 3. And then it's going to be squared because I'm going to get it twice. On my right side, I want to add 55 and 9, which gives me 64. Then I want to use the square root method to solve. So I take the square root on both sides. That will get me x minus 3 on the left, and then plus or minus. The square root of 64 is a nice one, so I get 8. Then I want to go ahead and add 3 to both sides. So I get x equals 3 plus or minus 8. I'm going to have x equals 3 plus 8 and x equals 3 minus 8, because I can actually solve these two out because they are all real numbers. So on the first one, I get x equals 11. On the second one, I get x equals negative 5. Okay, number 8 wants me to solve using the quadratic formula. So remember, this is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in order to use this formula, I need my quadratic formula to be in standard form. So I want to subtract this 3x over to both sides. So I'm going to have 0 equals 9x squared minus 3x minus 10. My a is 9. My b is negative 3. And my c is negative 10. So then I want to go ahead and plug into this formula. I'm going to have negative from the formula, negative 3 from the b value, plus or minus the square root of negative 3 squared, minus 4 times my a value of 9 times my c value of negative 10, divide by 2 times my a value of 9. So then I can go ahead and type this into my calculator. I can go to math, and then if I arrow over to the fraction option, oops, that's off the screen. It gives me n over d. I press enter, and then I can type my whole numerator in there. So my first negative is the one on the bottom of the calculator, parentheses, same negative for my 3. When I'm typing this into the calculator, I have to pick either plus or minus. So I'm going to start off with plus, and I'm going to do my square root, parentheses, negative 3 from the bottom of the calculator, squared. This is a minus, so the subtract sign right above the plus sign. And then 4, parentheses 9, parentheses negative from the bottom of the calculator, 10. Arrow down to the denominator, 2 parentheses 9. I press enter, which gets me 1.2. I didn't give you how many decimal places to round to. I want you to go to 2 decimal places. And then I need to go ahead and do the same thing for the subtract in the middle. So what I can do is I can press second, and then if I go down to the enter button right above it, it says entry. If I press that, it copies what I just typed, and then I can, if I arrow into my equation, I can change that plus sign into a minus sign, which gives me negative 0.90. Okay. This next one wants me to solve the polynomial equation. I have 4 terms, so I am going to factor by grouping. On my first group, I can take out an x squared, and I'm left with 2x minus 1, because remember, anything divided by itself is always 1. On the second group, I can take out a negative 9. I always want my leading term to be positive. So I'm going to have 2x plus 1. It still equals 0. Then what I do is I take my 2 outside terms and write those together. So I'm going to have x squared minus 9 times 2x minus 1 equals 0. Then I want to go ahead and see if I can factor this first term, which I can because it's a difference of squares. So I'm looking for what multiplies to negative 9 and adds to 0. This is positive 3 and negative 3. And then I have 2x minus 1. Then by the zero product property, I can take all of those values and set them equal to 0. And then I want to go ahead and solve all 3 of those. So the first one, I want to subtract 3 on both sides. I get x equals negative 3. The second one, I add 3 on both sides. I get x equals positive 3. And then the last one, I add 1. I get 2x equals 1. Then I divide both sides by 2. I get x equals 1/2. Okay. Number 10 wants me to find all my solutions. This one is a radical equation, so I want to start off by getting rid of that radical. I'm going to square both sides. So on my left side, 2x squared is 4x squared, because I square the number and the variable. On my right side, the radical and the exponent cancel out, so I'm just left with x plus 3. Then I want to go ahead and get all of my terms over to the same side, so I'm going to have 4x squared minus x minus 3 equals 0. This one, my a and c, or my a doesn't divide out, so I want to use the AC method. I'm going to take them. So my a is 4 and my c is negative 3. If I multiply those together, it gives me negative 12. I'm looking for 2 numbers that multiply to negative 12 and add up to negative 1. So that's going to be negative 4 and positive 3. So I want to split up my middle terms. I'm going to have 4x squared, and then I'm going to have minus 4x plus 3x, and then my last term stays the same, minus 3 equals 0. Then what I want to do is I can go ahead and factor this by grouping now that I have 4 terms. So I can split this first one up and the second one up. So if I look at my first group, I'm looking for what they have in common. I can pull out a 4x from both of them. So I'm going to write the 4x out front, and then I'm going to have x minus 1. On my second group, I can pull out a 3. So I'm going to write plus 3, and then x minus 1 equals 0. Then I want to put my outside terms together. So I'm going to have 4x plus 3 times x minus 1 equals 0. And then I want to take each of those and set them equal to 0. Again, I'll give you more room on the test. But let me do this off the side. So I have 4x plus 3 equals 0. And then I'm going to have x minus 1 equals 0. So for the first one, I subtract 3 on both sides. I get 4x equals negative 3. Divide by 4. I get x equals negative 3/4. For my last one, I add 1 to both sides. I get x equals 1. Okay. Number 11, on number 10, I forgot to go ahead and check my answers because this was a radical. Sometimes I get answers that don't always work. So I don't want to box those off quite yet. So this one was negative 3/4, and this one was 1. So I'm going to check these above. Like I said, I'll definitely give you way more room on the test. But I want to check those. So I'm going to plug those in. I'm going to start off with the negative 3/4 because that was the first answer I got. So on the left side, oh wait, there was no squared on the left side. I have 2 times negative 3/4, which gets me negative 3/2 equals the square root of, and I can add negative 3/4 and 3 on my calculator. Now if I go math, enter, enter, it turns it back into a fraction. So 9/4. Whenever I have a square root, that's already printed on the paper, it has to give me a positive answer. So this answer doesn't work. So it's not going to equal negative 3/4. So then I also want to go ahead and check my 1. So for this one, I'm going to have 2 times 1 equals the square root of 1 plus 3. 2 times 1 is 2. Square root of 1 plus 3 is 4. And the square root of 4 is a positive 2. So my only answer on number 10 is this 1. Again, I will give you way more room on the test. Okay, number 11 wants me to find all of the solutions to the equation algebraically. So same thing as number 10, except this time I have 2 radicals. So I'm going to start off by making sure one of my radicals is isolated and then squaring both sides. When I square my left side, I just get x plus 1. When I square my right side, I want to write this out twice so I don't forget that I have middle terms, because I've seen a lot of you make the mistake of squaring the outsides and forgetting that there's middle terms in there. So what I want to do is I want to distribute. 2 times 2 is 4. 2 times negative square root of x is negative 2 square root of x. Negative square root of x times 2 is negative 2 square root of x. Negative square root of x times negative square root of x is just x. Those square roots will cancel out. Then I want to go ahead and combine like terms. So I still have x plus 1 on the left. I'm going to write my radicals out front. So I'm going to have negative 4 square root of x because I added those negative 2's together. And then I'm going to have the 4 and x at the end. I want to go ahead and subtract from both sides. So I'm going to subtract the x and subtract the 4. So that x's cancel out, and I just have negative 3 equals negative 4 square root of x. I want to go ahead and square both sides since I just have a number out front and a value on the other side. So I square. This is going to give me 9 equals, the square goes to both the 4, which is 16, and then goes to the radical and cancels out, which gives me x. I want to go ahead and divide both sides by 16, which gets me x equals 9 over 16. I need to go check my answer. So I will write this off to the side. So I'm going to do the square root of 9 over 16 plus 1 should equal 2 minus the square root of 9 over 16. So I am going to type in my left side into my calculator. I'm going to go second square root, 9 divided by 16 plus 1 gives me 1.25. So then I want to check the right side. I have 2 minus the square root of 9 divided by 16, which gives me 1.25. Both sides give me the same answer, so this is my answer. If it didn't work, I would just write no solution. Okay, number 12 wants me to find all of the solutions to the equation algebraically. So for this one, just like the radicals, I need to isolate my part that has the exponent. I'm going to start off by subtracting 10. It's going to give me negative 64 equals negative parentheses x minus 10 to the 3 halves. I want to divide out this negative, so I'm going to divide both sides by negative 1. I get positive 64 equals x minus 10 to the 3 halves. To get rid of a fraction exponent, I raise both sides to the reciprocal exponent, which is going to be 2/3. Then on my calculator, I just need to go ahead and type this in. So I'm going to do 64, and then the exponent button is right above divides. And then I'm going to write 2 divided by 3, which gives me 16. On my right side, the exponents will cancel out, and I just have x minus 10. Then I want to add 10 to both sides. I get x equals 26. Just like with the radicals, I want to check my answer. So I should get negative 54 when I plug in. Oops, that's kind of off my screen. So then I'm going to type in the entire right side. I'm going to have 10 minus parentheses 26 minus 10 raised to the 3 halves power, which gives me negative 54. So this answer works. Okay, then the last two I have are inequalities. Number 13 wants me to solve it algebraically, so by hand. I am going to add the 65x to both sides because I like working with positive x terms. So I'm going to have 19 is less than 63x plus 41. I want to go ahead and divide or subtract 41 from both sides, which gives me negative 60 is less than 63x. I want to then divide both sides by 63, which gets me, this one I'm going to simplify on the calculator. So I have negative 60 divided by 63. If I go math, fraction, enter, it simplifies it to me, which is negative 20 over 21 is less than x. Typically we write the x out front, so I'm going to flip it. X is greater than negative 20 over 21. Okay. Number 14 wants me to solve it graphically, so in order to do this, I need one side to be 0. So I'm going to subtract 6 on both sides. I have 0 is greater than or equal to x squared minus x minus 6. And then again, I'll write it so that my inequality, so my variables are on the left side of the inequality. I'm going to have x squared minus x minus 6, and then less than 0, because whenever I flip the sides, I flip the sign. Then I want to go type this equation into my calculator. So I want to clear out anything else that's there. I have x squared minus x minus 6. And I want to graph this, which I'm going to sketch a graph out. You don't have to, but this is so I can refer to it. Then I want to find the 0 here and right here. So I'm going to go second, trace. I'm going to find my 0 on that left side. So I want to go to the left side of that first 0, press enter, cross the x-axis, press enter twice. That one is negative 2. Then I'm going to go do the same thing for the one on the right side. This time the left side is underneath, so I'm going to press enter, arrow over to the right, press enter twice. This one is positive 3. And I want values that are less than or equal to 0. So this means below the x-axis. And I can include these values. So when I write them out, I want to use square brackets. When I'm below the x-axis, these two values connect. So I'm going to have -2 to 3. And then they get square brackets because of the equals sign underneath. If it had just been a regular less than, I would use parentheses.